Welcome back to Intellify. I'm Rasika Ramakrishna and let's continue with the chapter on polynomials. As 2.3, question number 3. Obtain all the zeros of 3x to the power of 4 plus 6x cubed minus 2x square minus 10x minus 5 if two of its zeros are positive root of 5 by 3 and negative root of 5 by 3. Alright, so what are we given? We're given that a polynomial is of degree 4 and what the polynomial is, and we're given two of its zeros as well. And what do we have to find? We have to find the other two zeros of the polynomial. So how do we go about this? Well, one way of thinking about this would be, is there any connection between the roots of the polynomials and its factors? If there is a link, then we can try and do some sort of division, right? So let's try and explore this thought. Alright, so let's try and understand the relationship between the zeros and factors of the polynomial if it exists. Alright, so I think I gave it away, but okay. So let's take a polynomial 3x squared minus x minus 4, some arbitrary polynomial, and assume that we have to find the zeros of this polynomial. So you would go ahead, split the middle term, express it as 3x minus 4 times x plus 1 equal to 0, and equate each term to 0, and you will have x equal to 4 by 3 or x equal to minus 1, right? So these are the zeros of the polynomials. But let's take a quick step back and let's go to this step. So what are these guys called? What is 3x minus 4 and what is x plus 1? Well, they are called the factors. So let's quickly look at what this process is called. It's called factorization. So essentially you're breaking down the polynomial and expressing it in terms of its factors, and using these factors we find the zeros, right? So there is one sort of link, as in using factors of a polynomial you can find the zeros. So given the zeros of a polynomial, can you find its factors? Well, the answer is pretty simple, right? Because if a and b are the zeros, then x minus a and x minus b are going to be the factors. You can verify this fact, but here if you want to just understand it on an intuitive level, look at this step. If you know that 4 by 3 and minus 1 are the roots of the polynomial, then obviously you know that the polynomial can be expressed as x minus 4 by 3 times x plus 1, right? About it for a while, it will make sense. So given a and b are zeros, we just said that x minus a and x minus b are going to be factors. So if x minus a and x minus b are going to be factors, then x minus a times x minus b is also going to be the factor, right? In most cases, it will be the polynomial itself, in case we're talking about 2-degree polynomials. If we're talking about higher degree polynomials, then this is definitely going to be a factor. So what do we mean by a factor? It will completely divide the given polynomial. Alright, so with this new information, let's look at the question we have. So alright, so now let's get to our question. So we are given a polynomial of degree 4 and we are given two roots of this polynomial. So how do we find the other two roots? Okay, so first I would suggest we look at this particular question. So assume that you are given a number and one of its factors. How do you find the other factor or factors? Say you're given 12 and you're given one factor to be 3. Obviously, you can say that the other factor is 4. That is, you don't need to know anything about 12 per se. You don't need to know that 2 or 6 or anything else is a factor. But you can immediately say 4 is a factor. So how did you say that? Well, because 12 divided by 3 is 4. So, I mean, that example might have seemed pretty lame, but I'm getting to a very important point here, and that's why I used that example. So, I'm saying that I'm giving you an additional hint as well. So, whenever a quantity is divided by its factor, the remainder is 0. So we have the division algorithm. This is by the division algorithm. So whenever you divide something by a factor, the remainder is 0. So using these two facts, can we try and devise a strategy to find the other two roots of the polynomial? Well, first what we do is we divide the polynomial by the factor g, which is nothing but the product of the factors obtained from the two given roots, right? So now that you divide it, you will have the quotient. And what you do is you factorize the quotient and obtain the zeros. The quotient is also going to be a factor, right? Just like how in the case of 12 and 3, 12 divided by 3 is going to be 4, and 4 is also a factor of 12, right? So your quotient is also going to be a factor of the polynomial. So therefore you can factorize this quotient and obtain the zeros, and these zeros are going to be the zeros of your polynomial as well. Therefore, the given zeros plus the zeros obtained by factorizing the quotient are equal to the zeros of the polynomial. So spend some time on this slide to understand why we are going to go about this question in this way. But I'm sure it's pretty easy to understand. Alright, so let's go ahead and find the other two roots. So we're given that positive root of 5 by 3 and negative root of 5 by 3 are the zeros of the polynomial, which implies that x minus root of 5 by 3 into x plus root of 5 by 3 is going to be a factor. So let's go ahead with the multiplication, we will have 3x square minus 5 upon simplification to be the factor of f of x. So going by our strategy, we have to divide the given polynomial by 3x square minus 5. So we divide 3x to the power of 4 plus 6x cubed minus 2x square minus 10x minus 5 by 3x square minus 5, and we have the quotient to be x square plus 2x plus 1 and the remainder to be 0. So now that we have obtained the quotient, what we do is we go ahead and factorize the quotient. That is what we decided we would do. So we factorize x square plus 2x plus 1. So if you are very strong with your algebraic identities, in one look you will probably say that this is x plus 1 the whole square. But in case you did not guess it, we can still go ahead and split the middle term, and you have x plus 1 into x plus 1 equal to 0, which implies that x is equal to minus 1 comma minus 1. That is, minus 1 is the 0 of multiplicity 2. Therefore, the zeros of the polynomial are positive root of 5 by 3, negative root of 5 by 3, minus 1 and minus 1.